During the last ice age, something truly unusual occurred on the North Island of New Zealand, as two island-altering eruptions of a magnitude which each only occur somewhere on the planet about once every 1,000 years were about to occur not only within 3 days of each other, but these two eruption sites were only spaced 35 kilometers apart. This unusual sequence began 240,000 years ago when a cataclysmic volcanic eruption began at the site of what is now the modern Rotorua Lake. All at once, multiple vents along a several kilometer long fissure exploded, sending a plume of ash more than 50 kilometers into the atmosphere. Part of the eruption column then collapsed downwards and fell back to the ground, advancing across the dense forest landscape as 500 degrees Celsius pyroclastic flows. These pyroclastic flows contain a substantial amount of energy, going on to destroy an area of 5,200 square kilometers, traveling up to 41 kilometers distant. Due to the substantial amount of volcanic rock being ejected, it did not take long for more than 100 meters thick of rock to pile up across sections of the North Island. Then, an 18-kilometer wide patch of ground collapsed downwards to fill the empty space created by a now nearly empty magma chamber beneath it. This collapse formed the large Rotorua caldera in an eruption which ejected 339 cubic kilometers of tephra and had a volcanic explosivity index of a 7. In the following hours, another significant earthquake sequence began, but this time 35 kilometers to the southwest. Tens of thousands of earthquakes followed, repeatedly shaking the island until a second cataclysmic eruption began only 72 hours after Rotorua's eruption ceased. This eruption would also devastate a wide area as the pyroclastic flows it generated burned all vegetation in an up to 23-kilometer radius, destroying more than 1,700 square kilometers of forest. Once again, a thick amount of volcanic deposits piled up, totaling more than 100 feet thick in some areas, and settling right on top of Rotorua's eruption deposits. This eruption ended a few days later with the creation of the 8.5 kilometer wide and 7.2 kilometer wide Ohakuri caldera. In total, 100 cubic kilometers of tephra was ejected, and this eruption was also assigned a volcanic explosivity index of a 7. We know that these two powerful volcanic eruptions occurred within only a few days of each other because of one simple fact. The layer of volcanic rock at the very top of Rotorua's deposit showed no evidence of alteration or compression caused by rainfall. In other words, the two distinct eruptions occurred so close in time that it did not rain even once after the first eruption ended before the second eruption began. In New Zealand, this section of the country in modern times experiences rain more than 150 days a year. Yet, 240,000 years ago, the island's climate was slightly colder, meaning it only rained about 120 days a year. And this is how I arrived at my 3-day figure. In modern times, it is unheard of for two VEI-7 eruptions to occur right after one another, even spaced only a few years apart. Thus, the odds that these two eruptions, which occurred so close in time and distance to one another, were only a coincidence is 1 in 35 million. So, how do these two powerful eruptions occur in rapid succession, as it seemingly appears that one triggered the other? To this I say that there are a few possibilities, but here is what is known. Deep in the crust, 240,000 years ago, these two volcanoes were supplied by the same very large layer of magma mush. Also, when a caldera forms, it often generates large magnitude earthquakes. And sometime after the first eruption occurred, the Horo fault line, which connected directly to the eventual second eruption site, suddenly sunk on its eastern side, where a large graben perhaps lost more than 200 meters in height as it subsided downwards to fill empty space in the deep magma mush region. Possibility 1 is that this sinking of the graben caused magma which is already at less than 200 meters depth in Ohakuri to erupt as it became exposed to air on a section of the displaced Horo fault line. Possibility 2 is that the caldera collapse resulting from the first eruption caused compression in the deep magma mush area, causing some of that material to shoot upwards via a path of least resistance represented by the second volcano. Possibility 3 is that a large earthquake, perhaps in the magnitude 6 range that was caused by the first caldera collapse, created enough ground shaking at the eventual second eruption site, triggering either different magma compositions to mix or widening a gap between a fault line that allowed for magma to shoot upwards towards the surface and erupt. Whichever of these possibilities is correct is unclear, but Ohakuri was probably going to erupt in less than 1,000 years' time 240,000 years ago had the eruption of Rotorua not occurred. Thanks for watching. I would like to thank this channel's patrons on Patreon and channel members on YouTube.